All right, we made it to the last page of the packet. So this problem is kind of similar to number 9. It says particle moves along the x-axis. Now the velocity is this, measured in meters per second. Find the displacement from 0 to 6, and then find the total distance from 0 to 6. So let's see. So displacement is the integral from 0 to 6 of t squared minus t minus 20 dt. All right, so what's that going to be? That's going to be t to the third over 3 minus t squared over 2 minus 20t, going from 6 to 0. 6 to the third, let's see, what's 36 times 6? I should probably know this, but over 216. Yes? Okay, so 216 over 3. Is that divisible? Yes, because if I add these digits, let's see, 2 plus 1 plus 6 is 9. So that is divisible by 3. That's 72, right? Okay, so 72. 36 over 2 is minus 18 minus 120. And then when I plug in zeros, I'm going to get minus 0. So let's see. So what is this? 72 minus 18. So that's 62. And then minus 8 is 54, right? my calculation skills are struggling today. So yeah, I think that's good. And then minus 120. So 120 minus 50 is going to be, so that's going to be negative 70, and then minus, subtract 4 from 70, so you're going to get negative 66. Gosh, I hope that's right. Negative 66 meters. We'll have to see if we keep this or not, if my answer is right. Okay, and then total distance. Total distance means the absolute value from 0 to 6 of the integral from 0 to 6 of the absolute value of this, which means we are going to either figure out where the graph is negative. So we can say, okay, it's got negative 4 to 5. It's got those zeros, but we're only looking at 0 to 6. So 0 to 5 is going to have to get a negative on it. Add to that 5 to 6, which is a positive area. Now, in interest of time, and just to make sure that you know how easy it is with the calculator, I'm not going to have absolute values around this. I am going to use a calculator to do this because I'm running out of time this bell and won't have another chance today to record. So I could do all this, plug in the numbers, figure out the math. I'm likely to make a mistake doing that. So let's just math 9. If I'm allowed a calculator, I don't even bother finding the antiderivative. I just say math absolute value, type in what I have, and put an X over there. So I'm getting 75.6 repeating. I could change that to a fraction if I'm really worried. Oh, no, I couldn't. I could probably have a fraction answer if I did this by hand, but I'm just going to round this to 76.667. That's meters. It's a distance traveled. Good sign that it's in the ballpark of my other one. My other one's negative, but again, distance traveled is just saying like how far are you going here. So actually, you know what? Let's see if my other answer was right while we're in here. 0 to 6 of just don't put in the absolute value. If I messed up, then I don't know. You can find where I messed up and let me know. Oh no, hey, I did it right. Okay, so we're good for those. All right, number 2. The acceleration of an object moving on a line is given by this. Find the change in position from 0 to pi. The object is at rest. V of 0 is 0. So in order to get a change in position, we need a velocity function. In order to get a velocity function, we integrate the acceleration function. Now, this acceleration function has an angle other than just t. So we need a little bit of u sub happening here. U is going to be pi over 3t. Du dt is going to be pi over 3. Remember, you can always solve this for dt. So that would be 3 over pi times du is equal to dt. If you can skip the little solving step and just say, oh, I need a pi over 3 here, so I'll balance it with a 3 over pi, I'm good with that. If that does not mean anything to you, then don't worry about it. Just go through the little algebra work here. So I have a constant of 3 over pi times the integral of sine u du. Now I can integrate 3 over pi times the integral of sine is negative cosine, u, plus c. And then I need to solve. This is my v of t equation. So I need to plug in 0 for v and plug in 0 for t. So negative 3 over pi times the cosine of 0. Cosine of 0 is 1. So negative 3 over pi plus c is equal to 0. So add 3 over pi. That's our value for c. So let's bring it up here. V of t is the negative 3 over pi times the cosine of t plus 3 over pi. Now, find the change in position, which means the integral from 0 to pi of negative 3 over pi cosine of, not t, cosine of, that could be an issue, right? Cosine of pi over 3t, right? Because it was cosine of u, and I need to sub that back in. When I put in 0, that didn't matter, but let me just fix my work there. So that's going to be pi over 3 times 0 plus c. Still get the same c value. For pi dt. Okay, let's do this one now. So this is, again, u sub is out here. So let's break this up. Negative 3 over pi times the integral from 0 to pi of the cosine of pi over 3t dt plus 3 over pi times the integral from 0 to pi of dt. I like breaking it up like this because I need u sub for this first part, but not the second part. So u is pi over 3t. Du dt again is pi over 3. That means we're going to sub in 3 pi times du to get dt. So if I'm putting another 3 pi out here, that's going to make this negative 9 over pi times the integral from 0 to pi of cosine u du. Plus, what about this? We can integrate here. 3 over pi. What's the integral of dt? T. So no u sub there. I did not change my bounds because I'm just going to turn around and put this in. So negative 9 over pi times sine of what's u? Pi over 3t from pi to 0 plus 3 over pi minus 0. Now, we're not going to be able to find exact answers for this. Negative 9 over pi, this is going to be times sine of pi squared over 3 minus sine of 0 plus 3 over pi times pi is 3 minus 0. So I'm just getting negative 9 over pi times whatever sine of pi squared over 3 is, minus 0 plus 3. Hopefully, if I plug in this into my calculator, I get the same thing as whatever this comes out to.